let's take a look at another example. So for this example, we want to find all of our terminal currents, IB, IC, IE. We also want to find our collector emitter voltage, and we're told to assume that VBE on is 0.7, VCE sat is 0.2, and beta is 100. And so we see the circuit configuration is the same as what we saw in our previous example. We just have a couple minor changes. We've doubled our VBB voltage from 4 to 8, and we've doubled our RC from 2K to 4K. So let's sort of do the same approach that we did last time and see if we can't figure out what some of these values are. So as we did last time, let's start with our base emitter loop. So doing KVL on that base emitter loop, we can figure out our base current. So we can say IB is equal to our VBB, which is 8, minus, so let's assume forward active mode. So we say VBE is equal to VBE on of 0.7, divide that by the resistance RB, so 220K, and we get that this is approximately 33.2 microamps. Okay, so there's our IB. So again, we had said we assumed forward active, so let me write that explicitly. So assuming forward active mode, we know that our IC is equal to beta IB. So our beta in this case is 100, so that's another slight change from our previous example. And we have that this IB was 33.2 microamps. And so that gives us a collector current of approximately 3.32 milliamps. All right, so we could of course find our emitter current by combining those two, but let's go ahead and find our VCE by looking at our collector emitter loop here. So again, we can find the voltage dropped across that 4K ohm resistor, so we're just going to subtract that from 10 to get our VCE. So we can say that our VCE is going to be equal to 10. So I'm going to say 10 volts minus, and then approximately, because I have an approximate IC current, so 4K times our 3.32 milliamps, and that gives us approximately negative 3.27 volts. Well, so now we have an issue, because a negative VCE voltage means that our BC junction is going to be forward biased. So negative VCE indicates BC junction forward biased, which would mean that we're not in the forward active mode. So not in forward active mode. So what we did is we've made an incorrect assumption. So coming back up here, we can't say that IB and IC as we calculated above are true, and of course this VCE is not going to be true either. So let's switch up our assumption, and instead of forward active mode, which we now know is incorrect, let's assume that we're operating in saturation. So assume we're in our saturation mode or saturation region. And so if we're assuming this, the first thing that we can say is that our VCE is now equal to VCE sat, which was given in the problem statement as 0.2 volts. Okay, so now right off the bat, we know our VCE value. So now we're sort of going to work backwards. So we can say our IC, we're again going to look at KVL on this collector emitter loop, except now we know our 10 volts and we know our VCE, so we can figure out our IC by using KVL and Ohm's law. So we can say our IC is equal to the VCC value, which is 10, minus VCE sat, which is 0.2, divided by that RC, which is 4K. So plugging that in, we get 2.45 milliamps. And so I've actually misspoke earlier. So our base current up here is actually still correct, because our 8 volts is still enough to forward bias this BE junction because it's grounded on the other side. It's just that with our VCE being negative, we don't have our base collector junction reverse biased. So that base current is still correct, and so now we can use that 33.2 microamps with our updated IC to find our emitter current. So we can say our emitter current is IC plus IB, and that is approximately equal to our 2.45 milliamps plus, if we put that other one in milliamps as well, our base current becomes 0.0332 milliamps, and our emitter current is then 2.48 milliamps. So again, we can see that our emitter current is approximately equal to our collector current. So what we can note as well is that our ratio of IC over IB is about 74. And as we talked about, this would be equal to our beta force, we could call it. And we notice that this beta force is less than our beta value given in the problem of 100. Sort of another way that we can see this is, of course, we would have expected an IC of 3.32 milliamps if we were in forward active mode, but what we actually see is less than that. We see 2.45 milliamps. In the next video, what we're going to do is we're going to come back and sort of look at this more generally and see if we can plot sort of the response of our circuit as we sort of sweep this voltage here on our base.